Hello everyone, this is Mohit Gowda, pursuing my education in Sri Venkateswara College of Engineering, bearing the USN 1VE 21 CS 101 from Department CSC. Today we are going to learn about pointer aliasing in microcontrollers and about embedded system. As we know, microcontroller is a small and low-cost microcomputer which is designed to perform the specific task of embedded systems like displaying microwaves, information, receiving remote signals, etc. The general microcontrollers consist of the processor, the memory, RAM, ROM, EROM, serial ports, peripherals like timers, counters, etc. Microcontrollers are used in automatically controlled products and devices such as automobile engine, control system, implantable medical devices, remote controls, official office machines, appliances, power tools, toys, and other embedded systems. So, what is embedded system? An embedded system is a system that has software embedded into computer hardware, which makes a system dedicated for a variety of application or specific part of an application or product or part of a large system. An embedded system can be a small independent system or a large combination system. It is a microcontroller-based control system used to perform a specific task of operation. An embedded system is a combination of three major components. The first is hardware, second is application software, and the third one, real-time operating systems. As you can see on the screen, these are the embedded system applications which we use in our daily life. The applications of embedded system are consumer electronics include MP3 players, television sets, mobile phones, video game consoles, digital cameras, GPS receivers, and printers. Household appliances such as microwave ovens, washing machine, and dishwashers include embedded systems to provide flexibility, efficiency, and features. Advanced heating, ventilation, and air conditioning systems use network thermostats to more accurately and efficiently control temperature that can change by time of day and season. Home automation used wired and wireless networking can also be used to control lights, climate, security, audio, visual, surveillance, etc. All of which use embedded systems for sensing and controlling. So let's talk about pointer aliasing. Pointer aliasing happens when a single memory location is accessible through different symbolic means in the program. The name pointer aliasing applies specifically to accessing the memory location through pointers, although the same effect can be achieved when accessing the memory location through references or any other way. Pointer aliasing is notorious for breaking compiler optimizations and introducing hidden loop defenses. Consider the following example: void foo double star a double star b int n for int I is equals to 0, I is less than n with the increment I plus plus. bi plus is equals to ai. In case pointer a and b point to distinct memory blocks, this code perfectly parallelizable, but consider that someone call the function with the following arguments: for a comma a plus 1 n minus 1. If this is the case, pointer a and b aliases and the loop cannot be parallelized because of the control deficiency. The continuation of pointerizing. If a function has two pointer pa and pb with the same value, we say the pointer aliases each other. This introduces constraints on the order of instruction execution. If two write axes that allies occur in program order, they must happen in the same order on the processor and cannot be reordered. This is also the case for a write followed by a read or a read followed by a write. Two read access to aliases are safe to reorder because any pointer could alias any other pointer in C. The compiler must assume that memory regions accessed through these pointers can overlap, which prevents many possible optimization. C++ enables more optimizations as pointer arguments will not be treated as possible aliases if they point to different types. C99 introduces the restrict keyword that specifies that a particular pointer argument does not alias with any other. If you knew that pointers do not overlap, using this keyword to give the compiler this information can yield significant improvements. The restrict keyword qualifies the pointer and not the object being pointed to. So what is aliasing? Aliasing refers to the situation where the same memory location can be accessed using different names. For example, if a function takes two pointers a and b have the same value, then the name a0 alias the name b0, that is, we say the pointer a and b alias each other. Below is the program to illustrate the aliasing in the above program. The value of data is 20. When this variable is aliased to function gfg bracket, then the changes made to memory location referred by a pointer b got reflected in a as well. This is done because they refer to the same memory location. Strict aliasing. GCC compiler makes an assumption that pointer of different types will be never point to the same memory location. That is, it alias of each other. Strict aliasing rule helps the compiler to optimize the code. The strict aliasing rule is enabled by default and on optimization levels 2 and beyond. And when one tries to compile a program with a aforementioned detail, the compiler throws warnings through the program which still compiles and can be executed, and the output of such a program remains performance implications of pointer aliasing. Void process data, float in, float out, float gain, int NSA MPS. Int I for I is equals to 0, I is less than NSA MPS I plus plus. Out I is equals to in I into gain. In C or C++, it is legal for the parameters in and out to point to overlapping regions in memory. When this happens, in and out are said to be. So, what are the steps to avoid pointer aliasing? Do not rely on the compiler to eliminate common sub-expressions involving memory access. Instead, create new local variables to hold the expression. This ensures the expression is evaluated only once. Avoid taking the address of local variables. The variable may be inefficient to access from then on. So, thank you. This is the end of the explanation of pointer aliasing.